My name's David Wheeler. I'm at the OpenSSF, which is part of the Linux Foundation, and I have the distinct honor of attempting to moderate this panel of experts here. We're going to be talking about the strengthening software supply chains, and in particular, we're going to talk about things like SLSA and SPDX. So I think what we're going to do is we're going to start with some introductory remarks, 7-ish minutes each, and then we'll drop into kind of discussions and allow time for a couple questions. That's the general plan here. And so I'm going to ask each of them just to introduce themselves. So Mihai, I think we're going to start with you. So Mihai, if you can just make a couple remarks and get us started. So thank you very much.
Okay, hello everyone. I'm Mihai Maruseac from Google Open Source Security Team, Ghost. And under OpenSSF, I co-lead the AI/ML working group and the model signing project. And I am a maintainer for GUAC, a project under supply chain integrity and model signing. And I'm here to talk about SLSA, SLSA for AI, and so on in the context of supply chain security.
Go ahead.
Hi, I'm Kate Stewart. I work at the Linux Foundation. Mostly, you'll find me on a project called Zephyr or on ELISA when I'm talking about safety. However, I've also been a long-term member of the SPDX project, or System Package Data Exchange. And I see a couple of familiar faces in the audience, and so thank you for showing up. We've got SPDX has been around for, I guess, since 2009. I think we've been around that way, and it's been slowly and surely accreting use cases, use case by use case by use case. So do you want me to have my 7-minute talk right now, or do you want me to do the rest of intros?
Let's finish up the intros, and then we'll come back to Mihai to do your quick print. So go ahead, sir.
I'm Hasan Yasar. I'm working Carnegie Mellon University and teaching professor, as well as the director on the Software Engineering Institute. You may think Software Engineering Institute is part of CM as a degree program. Actually, it's a non-degree program. And my focus area is about making actionable software engineering concept, mainly for Department of Defense and Industry. So I'm managing the group that does the continuous deployment of capabilities and building up a CI/CD pipeline, creating a lot of scriptings, creating a lot of code, and sharing with the rest of the organizations, as well as DoD, as well as industry as well. And also, I'm the vice chair of the open groups. I did a lot of contribution for IEEE and ISO, working with the Linux Foundation folks, Kate and others a lot, and looking forward to have a great panel with together.
Okay, so Mihai, let's just go start with kind of an introductory and including SLSA and so on. So carry on.
Okay, so I can talk a little bit about SLSA. SLSA got created, I forgot exactly how many years ago, as a way to prevent future attacks like SolarWinds, where SolarWinds released the build system itself got compromised, and the artifacts were released with malicious software inside them, but because they were product of the build stuff, they were already signed. So anyone that got the artifacts from SolarWinds, they could verify the signature would pass, they would say like, okay, this is a legitimate artifact, but because the build itself got compromised, they would get malicious binaries. So SLSA got created to handle these scenarios into the future, the SLSA build track, which aims to tie the output of a build process to the build system itself, so you could record all the materials, or all the dependencies that got into the process with the build system itself. For example, if you use GitHub Actions, it will also tie it with the repository, with the action run identity, the run number, with the person that triggered the GitHub action. So you could look at the SLSA statement and identify exactly who has built the project and how it was built. And SLSA has several levels. Level 1 is just documentation. You document the build process. And the hardest level, you actually have the provenance is tamper-proof. The build is tamper-proof even during the build and after the build. This is the build track. SLSA now has 2 more tracks. One of them is the source track, making sure that even the Git commits themselves into the repository are properly handled, so you don't get malicious alterations on the source code. And Tom Hannon had a talk on this on Monday. It's also several levels. Level 1 is just you have some requirements on the commits. You keep the history, whereas the last level, every commit has to be reviewed, and you have to maintain the history. You cannot submit directly to main, and so on. And there is a talk on SLSA dependency track, which also is similar to S2C2F, another OpenSSF project. They are merging together to build the SLSA dependency track. And since now there are 3 tracks, there are also cross-cutting concerns between the tracks, like incident response and dependency management. If you go to salsa.dev, you'll see documentation for each one of these. SLSA just released RC1 1.2 release last week, and right now it's under comments until it will become a full released version in the near future.
Okay, Kate?
Well, so SPDX started in 2009, and use case by use case, problem by problem, we've been basically evolving it since then. At this point now, we are beyond software. We are systems, and we are able to start modeling systems, which includes the AI and the data sets. And this is now there for the SPDX 3.0, which came out last year. And so we've been working with security, working with the build profile, which was included in SPDX based on some of the discussions with some of the SLSA folks. So we had some harmonization that happened up front to make sure that things would flow reasonably well between the organizations. SPDX is moving more and more towards being able to manage things for product lines and be able to pull these efforts in together and be able to track this stuff over time. The 3.0, like I say, it's been out for a year. The tooling is now emerging, slowly and surely, thanks to some of the folks in this room in particular. I want to say thanks to Joshua and Gary, who've managed to give us our starting points, as well as some of the folks out of Japan. We're also, though, continuing to work beyond just what's happening with the AI, the data. We're also expanding into additional use cases so we can handle the safety use case. Specifically, we need to know provenance build and actually have accurate information from the builds for doing the safety analysis, as well as the hardware, and being able to model the hardware and model, quite frankly, the safety use case itself with requirements and traceability, so that we can actually start to make this stuff a lot more efficient. Right now, there's a lot of challenges when you're actually working with vulnerabilities in the sense that you think it's just a component. Realistically, it comes down to actually knowing which files actually made it into your builds and whether or not you're vulnerable, and making this all automated is something that we can do today in SPDX, and you're going to be seeing more of, I think, happening in the future.
Hasan?
Yes, great. So thank you. We heard about so far SLSA and SBOM, SPDX. Just going to start make it what does it really means to us as an engineers. If I hear anything about SBOM, if I say engineers or developer, can you create a SPDX format SBOM, especially when you say architect, you say, oh, it's not my job, right? If I say anything about developers, it's not my job either. But who's going to create SBOM? Who's going to create SPDX? Or if I say, let's say SLSA framework, which is another policy that we are talking about. So what I do, I'm trying to really connect the dots, make it actionable SBOM, make it actionable creation of the SPDX format, and also make sure that we are following the right standards. Mihai started. If anybody remember the SolarWinds case, SolarWinds was a perfect example how adversaries are able to change the code in the repositories, how adversaries are able to insert a malicious file into the build process. So we are receiving the signed artifacts. It looks like it's great because everybody's tracking the signature, because signature is the authentication from the company. It says I'm the person or organization are verifying the build artifact. But what is the problem here that we are trying to solve with the two combination of SLSA and SPDX, really putting into the actionable context on the application, build application lifecycle. That's actually the piece of the work needs to be automated, needs to be integrated because we can generate it. So what we do as the work-wise, we are making that actionable, make sure that we are building any CI/CD pipeline, which is DevOps pipeline. I'm sure you'll heard about it many, many times. But pipeline doesn't mean to go fast. That's what people are thinking about. Pipeline doesn't mean let's build up quickly, code as much as we can, make the business happy. But where's the security? And how do I know the pipeline is actually building the same thing over and over and again? Another analogy we were talking before the panel, make sure the connection to all of the points. We go eat the foods. We know the content of the foods. We looked at the menu, we looked at the items, which is SBOM technically, and then we looked at the recipes, which is the salsa. But who's going to authorize everything every time, make sure the quality is good? That's what the pipeline comes in the picture. So we have to make sure that we are using the pipeline. That pipeline has following the right framework, which is there are many tools like InTotal attestation, other things. We can make sure that we are following the right framework. That framework will produce the same result. If somebody changed the tools, how do I know somebody's changing the tools? If somebody's pushing new files into the picture, how do I know somebody's changing the rules? These are the things we should focus on, how things are built successfully and securely, and we can generate the bill of material as an output, as an artifacts on it. These are things we should think about it. So these are the challenge. If anybody does a CI/CD pipeline, please try to create SBOM automatically. If anybody is building the continuous integration or deployment, please follow the framework because you don't trust exactly go fast. Another thing, I'm going to bring my DevOps set. I have been teaching DevOps course since 2015 at the CS level in CMU. Every time when I hear that typical Google search, let's fail fast, learn fast, but we don't want to fail fast in the safety. I don't want to fail fast in the car. You want to fail fast in the car, you're going to die? I'm sorry, I can't do that. We have to fail fast early to learn early. That should be the right methodology. Of what we can do, again, we are building the safety in our components, but we should be ready. So this two framework help us to build up a secure system. And also we should be ready. And other things we should know as more recent response perspective. If something goes wrong, how do I know which file is actually causing the system level? How do I have a traceable in a big system? And I completely agree with Kate. We are looking for a very individual component, which goes back to the pipeline. When you build up the pipeline is specific to functionality. But we have to think about a system level. If you have anything that you in your home, it is not a single pipeline. Your refrigerator, your TV, and your IoT devices, your car. I don't want to go to the car, but there's so much components in it which we don't know. If you look at just the component software itself, we see the tip of the iceberg. So we think about the system level. That both things combining together in application lifecycle give us a full picture. How are we building things correctly, and how the output is actually following the bill of material. We're ready for any incident response that we're going to finish up here.
And I guess this is also taking us to the fact that data is now the equivalent of source. And so
Yes.
as we train models, there could be vulnerability, there could be issues and so forth happening from the AI data. So you need a very clear line of provenance of your training for your model and the data sets so that we can record this and then basically, when a problem happens, have a chance of understanding why.
So I've just got a couple kind of starting questions to kind of get things going here. So, and I'll probably just do it in the same order. So, Mihai, so I'm just going to keep abusing you a little further here, sir. So let's talk about adoption, if we could, a little bit. You know, where is adoption already happening? What's working? Maybe some gaps. But you know, where's adoption happening, and what are we seeing so far?
Yeah, so Salsa build track is already adopted quite well. So right now on GitHub, when you run a GitHub action, it also generates an attestation for you. And there is adoption with different workflows on Tecton chains, on GitLab, and different other build pipelines. For those, you actually need to edit your workflow to start using reusable workflows in order to reach higher level of Salsa, because otherwise somebody that compromises your build could also compromise the provenance that gets generated. For the source track, there is some initial proof of concept under an OpenSSF repository, and there is some attempt to also do this via a Git TAF. But this is yet to be proposed like a full standard. Right now it's just under the RC, so it's still under development. For the dependency track, all of the discussion happened with the merge to S2C2F. It's just at the discussion level. There is no proof of concept implementation right now. And now if we are looking at AI, Salsa for AI, we have a small demo of training a model on GitHub Actions and generating a Salsa provenance for that. But this is just proof of concept that we can generate Salsa for models. there is no developer, no ML developer that are going to train their models on GitHub Actions. So we actually need to do a lot of work to actually generate SLSA provenances for models. We need to go to ML pipelines, Jupyter notebooks, and so on, and make them able to generate SLSA provenances. And that's work that needs to happen this year, next year, under OpenSSF.
Awesome. Kate?
So we have a fairly strong adoption story for SPDX 2 in the industry. Most of the scanning tools, as well as some of the build flows, are already incorporating it. SPDX 3 has just released, and so the tooling is moving over now. I'd say our tooling is our biggest gap in SPDX 3 at this point in time. On the other hand, we actually have a very good, strong presence in the embedded space. This is one of the few places that SBOMs are perceived as a gap, but in SPDX we've got a really good story between what's happening with Yocto, and quite frankly, it just emerges automatically out of the build. You do some configuration work, and it just comes out. And quite frankly, with Yocto ones, for instance, you get the SBOM of the build toolchain that then is then used to compile everything, and you get the SBOM of the intermediate artifacts as well as the combined artifact at the end, and you have the precision to go to exactly what's there and what's not to be concerned about. And with Yocto, you have the full reproducibility. Similarly with Zephyr, we actually have SPDX 2.3, and it's about to come out with 3.0 now too. And so we can have the visibility happening at that level. There's various libraries of various states. In particular, the Java library is in very good, it's good shape, relatively speaking, helped to prove us everything out. We've got some gaps, I think, on probably still on the Python side, or at least we've got pretty close prototype there, but it still has a little bit of work to do. Similarly with Go, I think. So getting the reference libraries out there is certainly a big focus point for us for 3.0. And then tools building on top of that. So there are commercial tools that are starting to work with 3.0, but it is in early days for tool adoption from that perspective. However, that's not stopping us. We're continuing to work with SPDX 3.1, and we're basically looking at trying to figure out what we're going to need to do the safety cases. So this is where we're starting to look at hardware. We're starting to look at safety profiles, and we're starting to look at some of the other things like operations that people want to use and record information about operations for policy and policy analysis.
I'm going to add a couple of things here. So when I compare my DevOps, DevSecOps journey for the last 10 years, actually I saw a lot of adaptation. It's really moving fast and creating the bill of materials. If you are using any Docker desktop, anybody's Docker desktops in your environment? Anybody? If you install it, you will see a SBOM as part of it. It is getting there, so it's already available, but it is up to us as an engineer to utilize it, to dig it. We should not scare anything. Let's try. We always kind of see as something is new, it's an abstract, but it's actually give you an idea, give you the framework, give you the attributes. It is up to us to make it ready in our pipeline. As I said, many tools keep increasing in the community. Like GitLab has a plugin with the Gymnasium, which you can create a bill of materials as part of the source code. Or if you use any build artifacts, which we did all these years ago, build artifacts actually give an idea to create a bill of materials, an example. If you use any containers, already part of it. Any container scanning tool has built-in already in it. So it is that it's up to us to dig it and integrate it. So I saw a lot of adaptation. It's moving, but it's about the learning and also the changing the mindset. That is not there yet. So tool is available, but we have to change our processes and our ideas to create those files. It's the mindset we have to do, which goes back to the SLSA point, and Mihai said it. If we enforce some policies, that basically can enforce the people to use, to connect the dots. That portion is still struggling because our motivation is going fast still. Our motivation is really get functionality out of the door. And our motivation with engineers, get the functionalities, get it done. We kind of ignore the security, ignore the housekeeping work. We think about the overhead. If we enforce those framework and if we are able to see the value as an output, that makes saving life or saving the work and making it safe and safety and secure, I think that's portion we have to work as a team together. Make it safe as a safety, and it's affecting us, enforce the policy, we can produce it. So we are in that environment right now. I see a lot of push, but it is going to change eventually. So I don't see a lack of tool. It's available. Even though if it is not available, engineers can write a simple Python script created. It's not a rocket science. We should. Because framework is available. What is really missing? Write the code. And I know many engineers, they're writing some automation code already. If I know what the framework is, if I know what the attributes are, which is the JSON file, isn't that difficult to make it? No, we're just punting the ball at each other. So we should stop punting the ball, say, I'm responsible, let's work together. Then let's build it. So it is there, it is getting, but change the mindset is not there yet. So.
Okay, so obviously SLSA and SPDX, they're two different projects, but at least in my mind, the synergies are obvious, but it may not be obvious, or what I think is obvious may not be real. So can you talk a little bit about the synergies between these two? And I guess I'm just going to keep that order up. So that just means per Mihai is going to be on the hot spot every time. So Mihai, if you could get started.
Yes, sure. So SLSA point of view for the build track was the build process itself, how we generate the artifact and how we link the output artifact with the input. So it's more like a process document. And SBOM is complementary. You already have the artifact and you want to see what are the dependencies into it. So it's more at the end product. Both of them are serving useful information just from a different point of view. For Guac, we have ingested both SLSAs and SBOM documents. And actually, we find more information ingesting SBOM because you have all of the dependencies and transitive dependencies. Whereas with SLSA, you have to ingest one SLSA, get the materials, find the SLSA document for those materials, find the SLSA materials for the next ones, and so on. So it's a little bit more complicated process. But if you take both together, both SLSA and SBOM, you actually get accurate information into what got into the product, how the product was built, what was the build system. Maybe you might find out that some dependency was present during build, but not present into the SBOM, so that might have been a bug in the SBOM scanner, or might have been just a dependency that is not included into the final product and was ingested into the build product by a historical reason. It was like a new dependency installed but not used. So having both tools help you debug your build system, making it more performant, getting you more visibility into what it got into your software.
I'll just pretty much echo what you were saying. Having the information in the different formats, you can summarize it with SPDX to some extent if you don't want to have it. So you can just have like a master data if you're having to ship throughout your supply chain further. But having the information gives you a much more clear line of sight as to potential issues, especially as we move more towards the AI and the data side. I think we're going to need to see more of that showing up. And so that's one of the areas I think it's going to be quite interesting to watch as we emerge this stuff.
As I said at the beginning, actually, it's the two complementing things supporting each other. As I said, we need to know what is inside. So we need to know how are we doing well. Both is complementing each other. Because as one says, let's make sure that we are following right policies and procedural things. Other one is, let's create artifacts as a result of the policies and procedures. If we have one, if you don't have others, technically you don't know what you're building. You may have built pipeline every time, but if you don't know what ingredients looks like, how are you going to be ready for incident response? If I have items is generated, if I don't have the right process to produce the same output, then how can I respond? If I know it, but is it a matter of time to respond? Let's just one example for Log4j. Anybody remember Log4j? It's a good example. Log4j, finding Log4j vulnerability or the file in an organization, I advising one of the unit in a healthcare company, they spend 75% of time to find out do we have a Log4j or not. 75% of their time, which is SPDX and SBOM. Once I find that the Log4j is available in my network, am I ready to respond? Do I have a right process? Will generate the same thing. They spend more than 50% of their time to make sure they are building the right things. Isn't that the SLSA and SPDX we are talking about so far? That's exactly the problem organizations are dealing, keeping only one, ignoring other. We cannot ignore one. We have to make sure both are in the system that we are building. And people are trusting on us. If you are building any product in your organization, by design or by thinking, users are trusting on us. That's the reality. We use the phones, we use the car, we trust. Are we really building the good things that people are trusting on us? That's the question we should think about. That's kind of a connection, both SLSA and SPDX within an environment that makes us the combination of both, so we can build up a trusted systems. And for anything, for the software, for the component that we are building, with a system that we should think about. So that's kind of a synergy in between, both are complementing. We cannot choose one or the other. Both has to be in an environment that we are building. If you're using anything CI/CD, again, use both of them. We cannot say, here's an SBOM. So what, you have an SBOM, but what is the useful of SBOM? You generate it. If you don't visualize it, if you don't approve your processes, it's going to become a static data. But you should be dynamic. That's what is really bringing both together in an environment, automatically create, automatically verified, and then bring the results so we can be ready for response, and then also build up the same thing over and over and again if you change anything else.
So congratulations, as members of the panel, each of you has been given a crystal ball. So if you would briefly peer in and say, what do you think is at least somewhat likely to be happening over or in the future, say 5-ish or so years time, given what you know, given the insights that you're seeing in your particular situation? And yeah, we'll just same order again.
Okay, so let's say 10 years from now or 5 years from now.
Sure.
Looking at AI, imagine that we can generate SLSA provenances for every transformation of data sets, every transformation of a model. Each time you fine-tune a model, you get a new SLSA provenance for that. Each time you generate a checkpoint on a model, you get a SLSA provenance for that. And as you continue training, you keep getting SLSA provenances. And then at the end, you also get an SBOM once you put the model into production. You get an SBOM that also has the AI BOM field, so the data sets, the energy consumption, all the usages of the model that are expected to, all the evaluations of the model, and all the dependencies of the software that incorporates the model. Once you have all of this, you can imagine that you can also ingest this into a tool like Guac. And now imagine there is a scenario where some model gives a misprediction, gives a bad prediction. You can quickly inspect the entire chain of provenances and SBOMs and SLSA to find out exactly what is the culprit for the misprediction. And you could also go the other way. You discover that under some legislation, this data set reaches end of life, and you can no longer use it in trained models. And once you ingested all of the SLSA provenances, all of the SBOMs, you can quickly identify which models you need to retrain to be still compliant, without you having to waste money training additional models, or without risking not training one of the models that you're supposed to retrain because the data reached end of life.
Hasan?
So
I'm sorry, it's Kate first, and then that's
Kate,
fine.
you're first, you're next.
Kate, go ahead. We'll stick to the order.
So 5 years from now, what I'd like to be seeing is that we have continuous compliance of the safety use case when you do vulnerability fixes in open source. Anytime you have a vulnerability fix that comes into an open source project, you know you can still keep your the evidence for your safety analysis, be it for automotive, be it for medical devices, be it for aerospace, etc. Being able to say, hey, yes, we've patched this file, and yes, I can give you all the evidence necessary to prove that we are still safe. And being able to have that all automated so that you actually trust it behind the scenes. It's not done by scans afterwards. It's done in the build flows. It's done where it needs to be to have trust. And I think we're sort of nicely starting on that path for that. I think there's some work to still do, but I think that's the goal to aim for. Because right now, a lot of the safety people and the security people really don't like to talk to each other because they make each other's lives miserable. And we need to get past that, and I think we can get past that with automation in the right direction.
So before really starting the next 5 years things, I always been asked, what is really AI is going to take my job away or not? Anybody's believe that? Maybe. But I think we should think about AI as the statistical model. It's a software. It's built by us, first of all. We can use a lot of AI techniques to automate it. And what I see in the software engineering community, especially building the pipeline, we'll get a lot of benefits of using automation with the help of AI. With the help of the learning pieces based on what we are doing, what the contexts are that we are building, it will get improved. We will have much faster response. Now I'll be more comfortable say I will fail fast and learn fast because it's going to help me a lot. can help me a lot to get much faster, like using a calculator, not calculator. Calculator helped me out to get much faster calculation. So we should think about that perspective. When I look at it, I see a trend on automation, as Kate said, we're going to automate many data analysis pieces. We're going to automate analysis of the bill of materials, maybe the component made of impact. But still, human will be in the loop to verify and test it. To trust the piece is important. Still, we will see human will do. We're going to more effectively work on the process and improving. Yes, AI will improve, helping us, but we will be in the loop to verify well. We can approve many systems. We have many things we build. Our productivity will increase with the help of automations. I'm not going to say, yeah, help of the automation. That's what AI will do. Also, we have to think about building the AI system securely as well, as Mihai touched things. We don't really think right now to build up AI systems securely. Even the software, it looks like it's a total out-of-band building. I think we should think about to build up a machine learning pieces where we get the data out of it and what the parameters are and what the machine learning, how the model is behaving. These are things we should focus on building up AI systems securely. And what the components are, I think we should think about SPDX version and 3 has the AI BOM in it. We should really consider how things are building any ML components. What attributes are? We should focus on that. What I'm seeing in the future will get much better. Right now, it's really bad, but we should think about the future. It's going to get much better of building up a secure AI system so we can trust what automation is generating and keeping human in the loop. That's what I see in the next 5 years.
So we have a limited amount of time, but I wanted to just open up the floor to a couple questions before we end. So anybody has any questions? I did hint at this, that I'd do this earlier. So if anybody has any questions, and we have a brave volunteer.
This is a question for Mihai. How difficult would it be for a malicious actor to tamper with SLSA provenances?
So it mostly depends on the SLSA level. So right now on the build track, level 1 is just document the build process and doesn't say anything about the provenance. You could alter it after the build, you could alter it during the build, doesn't matter. Level 2 says the artifacts that you build should not be, you have a guarantee that the artifacts that you build are not tampered with, cannot be tampered with after the build, but the provenance might still be tampered with. It's not yet signed. And then it's signed at the end of the build. So from that point on, you cannot tamper with it. Level 3 says that both the artifacts and the provenance cannot be tampered with even during the build itself. So how this is generally implemented, the provenance is generated from somewhere else outside of your repository. So if somebody were to compromise your build system to compromise your artifact and also generate a valid SLSA provenance, they will actually have to compromise 2 separate systems, your repository and the repository that contains the reusable workflow that generates the SLSA provenance.
If I had a couple things here, it really depends on implementation. Let's think about a simple CI process. If the CI process is building the artifacts out of pulling different repositories, you should be catching out those repositories. Where it is stored, and then if there is no signature in it, as a signature file is built, and then that will be another way to check it out, the signature of the file and where it is stored, then you can see the changes of the file and it's out-of-band build, out-of-band changes. So it really depends on implementation, but it makes available to keep track those. And also another things we should really get away from a lot of human inputs, make it systems generate automatically with implementation and put a lot of alerts in it, which is another way you can catch it out. So it depends, but there's a lot of way to catch those tampering things based on the process, based on the flow. If you look at the one artifacts, it's hard to catch it. We have to look at the multiple things in the pipeline. We have to put the multiple sensors in the pipeline. One sensor is not enough, which we learned in the SolarWinds case. One sensor just building is not enough. We have to put multiple things and compare. That's what the provenance is going to tell us.
Do we have another question? Oh, and of course, I'm on the wrong side.
Of course. That's how it goes.
I'm going to get my exercise.
Thank you. I think this question is directed to Kate, but opened up. When it comes to attestation and non-repudiation of the different components in a build process, how can the standard, or how will the standard be evolving, perhaps it's already there, to record the signature for each contributor to that build?
So to a large extent, we've basically said that there'll be other systems around us to work with for the attestations. We basically will sign all the pieces of evidence, and so that you, anytime you're using a source file, you've got a hash of it, you've got some way of saying that this is there. However, there are other systems out there for doing attestation, and rather than trying to do everything inside SPDX, we figured, okay, that was a reasonable decision point. We can revise it realistically, okay? If someone comes to us and it makes a really good case for it, that's kind of how SPDX has evolved. It just takes someone coming to us and telling us this is why. But right now, we initially didn't want to, quite frankly, track the security because we figured there was X, there was other things that were doing that, but people came and convinced us that we should, and so we evolve it. But the attestation, like, the SLSA stuff, the Intoda stuff, there's other frameworks out there. And so rather than trying to do what they're doing, just leverage them. Is kind of what we've been thinking about at this point. I don't know.
Can I add something, Kate, again? I'm
Please.
sorry. And especially for verifying the output, and think about that you're creating artifacts on your build and deployment. Artifacts is just a package in binaries that we created. But the artifact should have another attribute, which is the bill of materials. Again, as we discussed, there are type of SBOMs, design, build, and deploy. And these are things we should attach into the artifacts on the system that we deploy. That used to be the same version of the artifacts. We usually ignore that component. We're just creating a independent of that files, but file has to be generated when I create a package of any deployments. It should be the pairing. And keep the same version again, which we can verify that it's created by the system with the hash value and with the signature, which attestation pieces. But mainly, we should keep track the package with the files together. It should not be separated out. If you separate it, you cannot keep track which version it is. And you always think about what if. What is which is we call as a kind of a secondary operation. Second up, what things happen in the operational? Do I know all the artifacts? Is it going to match with binaries that we build it? That should be traced together, and usually we don't pair together. We have different layers. We should pair it. That could be attestation what we should think about it. Is that clear, I hope?
Yeah, I'm very sad to say that our time is almost up. So what I'm going to do is I'm going to ask our panelists for about a minute-ish for each of you in the same order we've been doing. Kind of final last words. So either a point that's important that for some reason hasn't been already raised, or maybe a point that has been, but you really, really want to emphasize, or both. So each of you, a minute, whatever you think the final word should be as we leave. So start with you, Mihai.
Sure. So as you have seen, there is now the new OpenSSF security baseline, and one of the suggestions there is to make sure that everything that you release, every binary generated in the release, has a signature, has a provenance, has an SBOM. And that basically summarizes the synergy between all three components. The signature ensures that the binary cannot be tampered with. The SLSA provenance ensures that you know how the binary has been built, and the SBOM ensures that you know what has been in the binary and you can react to incidents faster.
We're living in an interesting regulatory environment right now. Like with the EU CRA Act, with things shifting here in the US, with all sorts of other things happening around the world, what actually is an SBOM is going to be subject to some discussion over the years. So having a format where we can say, these are the metadata fields that are important to track, and have tooling that can work with them, and so that it can shift with these varying definitions of SBOM depending on which country you're talking to or which industry you're talking to, I think is going to be a key. So keeping that in mind and recording as much metadata as you can as you're going through your builds, as you're going through your deploys, as you're going through your runtimes, will put you in a reasonably robust state as the ecosystem continues to evolve.
You get the last word.
Yes, so thank you again. What I really advise, two things for all of you as the kind of a takeaway. One is we should really trust and verify. Whenever you're downloading anywhere else anything, please trust, but you should verify. Look at your hash, look at the component that you created. The second is mindset changes. We are together in this journey. You're not alone. Please come join discuss, be part of the community. That's what the Linux Foundation does, what the community does. Ask. Don't try to solve the world by yourself. Always somebody, somewhere else in the world have the same problem like you have it. Just speak up and raise your hand and ask. And here's our email. Ask for us question. We are ready to say that. Thank you.
Thank you.
Would you please join me in thanking our panelists?